Hello, my name is Shadi Abu Dalfa. I am an assistant professor at the University College of Applied Sciences. It's my pleasure to present our paper, which is titled as Hybrid Deep-readout Echo State Network and Support Vector Machine with Feature Selection for Human Activity Recognition. This work is conducted in cooperation with Professor Kevin Borchard from Leiria Lab in University of Quebec at Chicoutimi. This presentation contains introduction, background, a description of our solution approach. I'll describe also an environment used to conduct our experiment work. Then I'll show some result and finally conclude the paper. As an introduction to this work, nobody can deny effect of healthcare on societies nowadays. And it's worth mentioning here that one of the most important tasks used with healthcare systems is referred to as human activity recognition. This task is involved in such systems by collecting data from some sensors. Then the data is transferred through wireless networks to healthcare systems. These systems may be also connected to internet to support some Internet of Things services. This means that any improvement in this area will result in an important impact on a large range of domains. Mainly, this task is achieved by employing machine learning techniques, thereby using sophisticated machine learning techniques reveal a significant improvement in human activity recognition. This encouraged us to explore performance of employing more machine learning techniques with the human activity recognition. The general framework for human activity recognition consists of some phases. The first phase is based on collecting data from some sensors. Then the next step is based on extracting feature from collecting data. Finally, one of classifiers should be used to classify feature vectors, which is referred to as data points. The output of this system will be activity labels. Thereby, each data point will be mapped to a specific class of activities. Now I'll describe our solution approach in details. Of course, firstly, we need to collect some data from some sensors. Then we should extract some feature from the collected data. After that, we applied feature selection to improve accuracy of activity recognition. We also applied data scaling for normalizing attribute values. Our main contribution is based on merging Echo State Network with support vector machine to improve accuracy of activity recognition. To merge both models, the presented technique applies ESN to the normalized data. Thereby, ESN will provide logits corresponding to data points. Then the presented technique will apply support vector machine to the same normalized data, and the output of support vector machine will be probabilities of prediction correspond to same data points. Finally, the presented technique will use both probabilities and logits to make final decision. Of course, the output will be activity labels. To show performance of the presented technique, we conducted numerous experiments. The environment used to conduct experiment work is based on using Python language. We used two machines to conduct the experiment work. First of them is a local machine, while the other one is a cloud supported by Google. We conducted our experiment work by using a dataset entitled Activities Exercise Recognition. This dataset includes 1,150 data points. This dataset is collected by Kevin team from Laria Laboratory at University of Quebec in Chicoutimi. This dataset is collected by using inertial central units. This team designed a device for collecting this data. The dataset includes 10 classes of activities collected from 10 participants. For example, this activity consists of two steps, and the second one clarify how to measure step down activity. The third one describe the activity of sit down. And so on. And this table shows a set of features used with the dataset. To show performance of the presented solution, we used a tool to visualize the dataset. We can see in this figure that the classes are unclear, but after applying feature selection, we can see now that the classes are well separated. So applying feature selection is a good process. Also, applying data scaling will improve the performance through normalizing attribute values. We also evaluated performance of ESN since it is a main component in our presented solution. This table shows a list of hyperparameters used for training ESN model. We also built a comparison framework for comparing the presented technique with other models. We compared our presented technique with support vector machine. We compared also our presented technique with ESN model. ESN model is composed of reservoir networks and a readout layer. Due to large number of hyperparameters used in ES model, a total of 500 random configurations are evaluated. Of course, using larger number of random configurations may reveal global optimum values, but we didn't investigate this matter further because it is a time consuming. We also compared the presented technique with an extension of ESN network, which is titled as bidirectional deep reservoir Echo State Network. This network based on using reservoir network. Then it uses principal component analysis to reduce number of dimensions. And finally, there are some layers of multiple layer perceptron. And of course, the output will be activity labels. This table shows a list of hyperparameters used to tuning bidirectional ESN. We can note that there are some intervals used to tuning these parameters, and these are the best values selected to tuning the parameters. We also compared our presented technique with another related work entitled ESN Support Vector Machine. This related work is based on using reservoir network, and the output of the reservoir network is used as input to support vector machine, and finally the output of support vector machine used to predict activity labels. So we can see clearly that this related work is different in using another technique for combining ESN with support vector machine. They use ESN and support vector machine as sequential process, but our presented solution is based on using both of ESN and support vector machine as parallel. This table illustrates the output of our comparison framework. In this comparison framework, we used tenfold validation to make the comparison fair enough. We can note that our presented technique outperforms the other models. We can note also that in each fold there are a competitive results provided by the presented technique. Thereby employing the presented technique with human activity recognition is a promising research direction. We also make some experiment to compare time complexity of these models. We can note clearly that the presented technique provides competitive results in comparison with bidirectional ESN and related work entitled ESN Support Vector Machine. To sum up, this work evaluates performance of applying echo state networks with feature selection to human activity recognition. We also present a technique for improving the performance of a human activity recognition. The experiment results show that performance of the presented technique outperforms performance of support vector machine, ESN, bidirectional ESN, and a related work entitled ESN SVM in terms of classification accuracy and F1 score. As future work, this research can be extended in different ways. For example, evaluating the presented technique by using more reservoir computing models, applying more feature selection methods, using optimization methods for finding optimal values of hyperparameters used with the presented technique. Of course, applying optimization methods will improve performance of the presented technique. Thanks for listening.